This is a dynamic optimization problem where we're going to try to maximize the final x2 value again at this final time tf. And we're going to be doing that by changing the values of u. If you change the value of u, we're subject to these constraints right here. And u, if you increase it and x1 is positive, then the slope of x2 is going to go up. Okay, so x2 is going to go up. We're going to try to do that. We're going to try to maximize the value of x2. But you'll also see here that as we increase the value of u, that we cause the value of x1 to go down. Okay, and if this turns negative here, then x2 is also going to go down as well. So it's going to be a trade-off. It's going to be an optimization problem to determine the value of u at all of the time steps into the future. So here I have time, and I can decide what values of u to put in to the system from 0 all the way to a final time of 1. Okay, so my final time is 1. And I can only choose values of u between 0 and 5. Okay, so 0 and 5, and so all the decisions that I have are what to put my u value at over this horizon. Okay, and as I decrease the delta t of these time steps, then it becomes more and more continuous. So I have to, I'm going to have a trade-off between how many points I want to solve at and the computational time as well. Okay, so two differential equations. I'll just write those there. We have an objective function, and then we also have some initial conditions, constraints on u. And we're going to go all the way to a final value of time equals 1. Okay, so start at 0 and go to 1. Okay, so the first thing that we'll need to do is get our model file, and so I'm going to I've just created an example3.apm file, and the first thing we need are some parameters, and so I'm just going to have a parameter p. I'll show you why we're going to have that in just a second. I have my value of u as well. Okay, so that's going to be going between 0 and 5, and okay, and then I have some variables as well. x1 is going to start with the value of 1, x2 is going to start with the value of 0. Then I have some equations. I want to maximize this parameter p times x2. And then I also have my first equation. The differential is just the $sign. Okay, so I have, this is just $sign x1 in my model. And then I'll have my x2 as well. Okay, so that's it for the model file. The next thing that I need to do is go ahead and create a data file as well. I need to tell it what points I want it to solve at. So I'll have my time, and I make this just a little bit bigger. You know what? I'll just keep it that size for now. 0, and then I'm going to do 0.0001, so 1,000th of a time interval, and then I'll put 0.1, 0.2, and then I want to go all the way to 1. And then the other thing I want to do is create this p-value, and I want that to be 0 everywhere except for the very last point, which is going to be 1. Okay, so what that does is essentially in my model, as I saw before, I had p times this x2 value, so it's only equal to 1 right at the end, and so I'm only going to be maximizing the value of x2 just right at the end, just like we had it stated here in our optimization problem. Okay, so that's our data file, and I'll just go ahead and save it. It'll ask you if you want to keep it in the CSV format. Just click yes. Okay, so comma separated value format, and when you close it, you can click don't save if you've already saved it. Okay, and the next thing I want to do is create a MATLAB and a Python, MATLAB and Python files. I'm going to go ahead and just split the window here, show the MATLAB on the left and the Python on the right. First thing I want to do is clear all the variables, close all the plots, and clear the screen in MATLAB. And then I'll assign a server name and an application name. Okay, in Python, I'll just have a server and an application name. MATLAB, I want to add path to the APM folder. That's going to be included in the download that I'll show you how to get in just a second. That'll be a MATLAB or Python file or a package for doing dynamic optimization. And then the first command that I want to send to the server with that application name is to clear that application from the server. I'll do that same thing in Python as well. I'll load my model file and load my data file with the APM load and CSV load. Okay, and then I'll have a number of nodes. So just come up with a couple of different options. These are a number of collocation nodes. By default, I believe it's 2. I'll have the APOPT solver, which is option 1. Then iMode is 6, which is dynamic optimization, and vtype is 1 for a linear interpolation. Again, same options there in Python. Then I want to create a manipulated variable, which is u. Now this just classifies certain variables as being special or giving them additional properties, like a tag that we would have in a distributed control system or PLC. And then that gives it things like status, which I can turn on, and delta cost. So if I move my manipulated variable, it might have a cost associated with that. I just set that equal to 0. Okay, same thing in Python as well. And then I want to solve. I'll do that in both MATLAB and in Python. Okay, display the output or print the output, and then just retrieve the solution with the APM underbar SOL function. Okay, and then display the optimal solution. Alright, if I move this way, you'll see that full line is just wrapped around there. Okay, next thing I'll do is just plot the results. Figure 1, do a subplot. Let me just go ahead and create this with u on the top, and then a subplot with x and 1 and x2 on the bottom. Put a legend, put a y label, put an x label, and I'm done. Okay, same thing in Python. I just need to import matplotlib.pyplot, and again, same thing. I'm going to create 2 subplots. First one, I'm going to put the value of u on it, and then the second one I'll put x1 and x2. Okay, the last thing I need to do is just show the plot. Okay, so that's it for the Python and the MATLAB. Let's go ahead and open it up now and run it. So these 6 things, I need those in the same folder. In this case, it's just on my desktop. I'm going to go ahead and just open up MATLAB, and while that's opening, I'll also open up Python, edit with IDLE. Okay, so there is my script. And then if I run it, then it's going to run, solve with the APOPT solver, and then finish. Let's see if it came up with the, okay, so there's the solution, there's the value of u, and then x1 and x2. Okay, and let's do the same thing in MATLAB as well. Run the same script, very similar. And let's see, okay, so there's the plot. If I come back to MATLAB, I'll see that it had the same solution. So it took about about 0.1 seconds, and you can see the objective and the optimal solution is 0.57. Just one difference here, the objective here versus here, we were maximizing, so we just converted that into a minimization problem by multiplying by -1. But there is the optimal solution. That's the value of x2 at the final point. So we were trying to maximize that, and that U profile there, that was the optimal sequence of inputs or manipulated variables in order to maximize the value of x2. Okay, if you'd like to download the source for this, come to APMonitor.com/do for dynamic optimization, and then on the right hand side you'll see benchmarks. Now go ahead and select that, and then if you scroll down, we just covered problem number 3, example 3, and you can download the source files there with the script in MATLAB and in Python.